within its cutoff mode. If the IC value is between 0 and its maximum value, that's the IC sat or the IC max, now we can calculate the IC value or the saturation current by using this formula. Let's say the IC sat will be equals to the VCC divided by the collector resistor plus the emitter resistor. This formula is when the emitter resistor is there. Now, if the emitter resistor is not in the circuit, it's just VCC divided by RC, where RC is the collector resistor. And if there was a load, let's say an LED, then the saturation current IC will be our VCC minus the voltage drop of the LED divided by the collector resistor. So we can use this to calculate the maximum saturation current at the collector, which is called IC sat. So now in the active region, the collector current can be defined by using the formula IC, which is equals to beta times IB. This means that as the beta goes up, the collector current also increase. And in the saturation region, if you increase the beta current IB, IC will not change. It will be at its maximum value. So that is how you know if you are in the saturation region. And then you can tell by measuring VCE. If you connect a digital multimeter between the collector and the emitter terminal of the transistor, if it is approximately 0, then the transistor is in its mode of saturation. So those are some ways in which you can determine if the transistor is in the cutoff region, the active region, and the saturation region. Now, transistors are classified by a number beginning with 2 and an N and 4 more digits. That's why they call it bipolar, right? Because it has 2 junctions as compared to a normal diode that has 1 and an N, because all diode has 1 junction. The package of a transistor serves as protection because these are very small, delicate devices. So we are going to mount them into a big package compared to their size. It provides a means of making electrical connections to the emitter, the base, and the collector. Typically, for most transistors, the active area of the component is extremely small, like the size of the head of a pin. So, in order for us to make electrical connections that we could solder to, what they will do is they will connect the head of the pin with wire about the size of our hair, and then what it does is it comes out to the leads, and then the leads penetrate through the component so you could solder into a circuit board. So inside that package are some really small wires that are actually connected to the active portion of the component. One of the big reasons for having a package is it's going to serve as a heat sink to draw heat away from that active area. That is, removing excess heat from the transistor, because as we know, if it is made up of solid state materials or semiconductor materials, where their biggest fault or problem is heat. So if we do not get that heat away from this stuff, it's going to burn and even catch fire. So most packages of the transistors are designed to rapidly pull that heat away from the active region. These packages are also designed by sizes and configurations. So this is actually called the TO, meaning transistor outline, which is the type of package of these NPN and PNP transistors. Now, generally speaking, it's pretty easy that the bigger the transistor, the more power it can handle. The basic functions of transistors are to provide current amplification of a signal and to switch a signal on and off. So in a transistor, a small change of the base voltage is going to bring about a large change of the collector current flowing through the device. So therefore, we can use it as an amplifier. Okay, now let's say an example of amplification could be me speaking into a microphone. The piezoelectric effect of the microphone is going to cause that vibration as a very small voltage. Let's say I get that very small voltage and let it pass through the base of the transistor, where that small voltage is going to control a large amount of current. Now all of a sudden I am amplifying my speech pattern into a microphone through a transistor. You dig this? The differences between these two types of transistors are the batteries or the supply voltages are going to have opposite polarities, right? Because we know that current flows the opposite way in a PNP transistor as compared to an NPN. And the direction of electron flow is also going to be reversed to a PNP as compared to an NPN transistor. For the NPN transistors, electrons are being emitted from the emitter, while for the PNP, the emitter emits holes, and those holes are collected by the collector. In a transistor, the barrier voltage, that is, its threshold voltage, is going to be produced across the base emitter junction. This will be determined by the type of semiconductor material used. For example, if we were using silicon, it will be from 0.6 to 0.7 volt. And if it was germanium, it will be from 0.2 to 0.3 volts. So these voltages are going to be developed between our base emitter junction VBE. Now the reverse bias voltage applied to the collector base junction is usually much higher than the forward bias base voltage across the base emitter junction. So, transistor failure can be caused by high temperature, high current, or high voltage. If it gets too hot, it's going to fail. If you put too much current through it or through the device, it will fail. Too much voltage can damage it. Its failure can also be caused by extreme mechanical stress, where it can break or crack. Generally speaking, when a transistor is defective, it's either going to be open or short, which is pretty easy to find with nothing more than a digital multimeter. And also note that a transistor characteristics may also alter enough to affect its operation. So this will not be pleasant, because what it will do is manifest itself as some unusual symptoms. We have two methods to determine the functionality of a transistor. The first method is by using either the digital multimeter or an analog multimeter. Digital multimeter is not pretty good to test them, but we can still use it as well to test transistors. In doing so, you have to set the digital multimeter for diode test, and basically what you are going to be looking for: high resistance one way and low resistance the other way. But if this resistance test is too high, our digital multimeter may not be able to give the correct reading. So the best will be to use an analog multimeter. With an analog multimeter, we have to go to resistance test, or you do your setting on resistance test. These resistance tests are made between two junctions of the following ways. From the base emitter, junction should be high one way and low the other way. From the collector to base junction should also be high one way and low the other way. Then finally, from the collector to emitter should be high both ways. All this means that in practice, with an analog multimeter set on resistance testing and connect any two terminals one way, then reverse the leads in one direction, the resistance should be high, about 10,000 ohms or more, and in the other connection the resistance should be lower, less than 10 kilo ohms.